Hey guys, David here. In this video, we'll look at a couple of data science interview questions asked in a real interview by some pretty known companies, Roblox and Revolut. In this series, we help you prepare for technical questions in data science and ML by devising answers that the interviewers expect. So the first question was actually asked by Roblox, and it reads, what is the CLT theorem and why do we care about it? Questions like these are important to get right. CLT is a fundamental concept in statistics. It states that the distribution of sample means follows a normal distribution as the sample size gets larger, regardless of population distribution. But what does that mean exactly? Well, imagine you want to get an accurate estimate of the height of the people in the world. You obviously can't get data on every single one of the 8 billion people, so you take multiple random samples. CLT tells us that if you take enough of these random samples and compute the average height in each one, the distribution of those averages will form a normal, bell-shaped curve, even if individual heights aren't perfectly normal. This matters because once the distribution of sample means is normal, we can use powerful tools like confidence intervals and hypothesis tests to make statistically sound inferences about the entire global population from just a sample. Now, what an interviewer would like to hear here is, apart from the definition, you have to tell how this relates specifically to data science and the work that data scientists do. And the answer is straightforward. In DS, we often deal with large data sets, and the job is to make inferences based on that. CLT allows us to do so and get a sense of population parameters. So let's give it a shot and see how well we do. If you're curious what platform I'm using here, it's NeuraPrep. What's cool about this one is that you can input your answer exactly like you would do in an interview, and you get good feedback as it already has the perfect solutions in the database. So let's go ahead and type our answer here. CLT states that the distribution of sample means approximates a normal distribution as the sample size gets larger, regardless of the population's distribution. CLT is useful to data scientists because it allows them to make inferences about population parameters. I'm pretty confident of this answer, so we will switch to single turn assessment to get a grade directly. Nice, seems we got a perfect score. You can see here that the interviewer looked after two ideas, which is the definition and the use case. Here we can actually see the marker's reasoning for grading us. Okay, now let's focus back on Glassdoor for the next interview question. The next question we're going to look at is from Revolut. Now here, there isn't a specific one being asked, but we can browse our knowledge base regarding regularization questions to see if we can find something and search for regularization here. There is one question from Revolut. Let's get into it. Describe the differences between L1 and L2 regularization. Mention as many as you know. So when you've got a question like this where maybe you don't know where to start because you've got so many differences in mind, it's good to organize your thoughts. The interviewer is likely expecting an answer from a theoretical perspective, but a practical one too. If you recall L1 and L2 regularization, one clear theoretical difference lies in the formula. L1 uses absolute values while L2 deals with squares. That should be good to cover the theoretical part. Let's look for what that means in practice. When you square something up, that thing becomes much bigger, right? If it's already big, that is. So naturally, L1 will be more robust to outliers since the big differences here do not escalate further. You might ask why the weights itself get bigger with an outlier. Well, the weights are updated in the direction of the gradient, which in case of an outlier could be quite drastic, leading to an instability of the weights. An important known practical effect of L1 versus L2 is that L1 tends to get parameters to 0, creating feature selection. You might ask, why would you ever use L2 over L1? And where here lies another difference. If you have two extremely correlated features, you will get more understandable results with L2 regression because the coefficients will be quite evenly distributed among the features. If you use L1, you can get coefficients that differ greatly in magnitude, even though they will probably be directionally the same. Now there are other differences, like L2 regularization making the cost function strictly convex, which has some advantages, but let's leave it there. Let's go back to the question in hand and formulate an answer. L1 penalizes large weights by using the sum of the absolute values, while L2 uses the square. L1 tends to be more robust to outliers and has a built-in feature selection process. L2 tends to handle multicollinearity better. Okay, let's submit it. So it appears that it does want a bit more. Yeah, we should probably mention that L2 solutions tend to be more non-sparse, that is implied, and L2 does make the loss function strictly convex. This concludes the 2 questions we had for today. We like to end each episode with a quick mock-up interview with Jessica, a cool, autonomous technical interviewer. Okay, so let's give it a shot. I selected a regularization question.
Hi there. I'm excited to start this interview with you. Let's dive in.
Yeah, let's do it. I'm ready, go for it.
All right, here's the question. How does dropout regularization help prevent overfitting in neural networks?
Well, for starters, just to define it, dropout regularization deactivates a subset of neurons during training.
Good start. Can you elaborate on why deactivating some neurons during training can actually help reduce overfitting?
Sure. The intuitive explanation of dropout, well, there are many, but I like to think that regularization prevents a network from overfitting by encouraging the development of redundant representations, since that helps performance on unseen data.
Great, that's exactly right. Thanks for your clear answer and for walking through the reasoning. That concludes my technical questions. Thanks for your time.
That was it, guys. Thanks for watching the video. Subscribe if you want to support this type of content. Leave us a message below and be sure to check out NeuraPrep.com for technical interview preparation.